Here's the AQA AS Maths papers from May 2018, paper 1, and we're looking at question 8, a logs question. And we're given a graph, and we're told that someone called Maxine believes that the pressure is equal to some constant little c times the volume to some value, some index little d. And we're going to find out what little c and little d are, and we're going to estimate the pressure at a certain point, and we're going to look at a point on the graph. Now let's start by reading off the graph, shall we? And we're looking at point A for part A. So I would say A is at, reading off the graph here, negative 0.15 is log to the base 10 of V, and 2.18 is log to the base 10 of P. And we're asked to find the value of P and the value of V at that data point. Well, if I know those two things, I think it's always useful to write down what I know about logs and use a bit of pattern recognition. So I know that 10 squared is 100, and I know that log to the base 10 of 100 is 2, and I'm going to use that sort of pattern recognition approach here. The 2 is that index, the 100's over there, and the base there is that number there. So let's do that again over here. Log to the base 10 of V is 0.15. That looks a bit like that. So using this sort of pattern, that log to the base 10 makes that index 10. It's equal to 2, which is negative 0.15 in this case. Would be log to the base 10 of V. Well, that's there is equal to V. So you can see how that and that translate together to give me that. And if I put that in a calculator, I get 10 to the power negative 0.15, which gives me 0.7079, etc., which is about 0.71 to 2 decimal places. And exactly the same idea for the second one. I'm looking at the pressure here, and I get 10, log to the base 10 of 100 is 2, so that 10 becomes that index. What was a 2 becomes what was over here, which is 2.18. And that becomes equal to P, so I put that in there. I'll get 100 in a bit, I guess. 10 to the power 2.18 is 151.356 something, which gives me about 151.36, again to 2 decimal places. Okay, there we are, that's that bit done. We're now asked to find the value of the constants C and D. So let's see how we do that. Here's part B. Now I've got a graph here, not of V versus P or P versus V, but my graph is log to the base 10 of P against log to the base 10 of V. And my equation that this person, Maxine, thinks governs these two ideas is that one there. So let's take logs of both sides there and see if I can make it look a bit similar. If I take logs of both sides, I get log to the base 10 of P equals log to the base 10 of CV to the power D. Let's simplify this a bit. If I've got log of a product, well, I can separate them out. So that becomes log to the base 10 of C plus log to the base 10 of V to the power D. And now I can use the fact that if I've got an index in my log, I can bring that out as a coefficient. And so I get log to the base 10 of C plus D lots of log to the base 10 of V. And that is an equation for my line that I get on my graph. Excuse me. Where this is going to be the intercept, the y-intercept, or in this case the log to the base 10 of P intercept, and this is going to be the gradient. So let's interpret these one by one from the graph. So now I would say from the graph, the intercept is, reading from it, 1.97, which tells me that log to the base 10 of C is 1.97. So C equals 10 to the power of 1.97, which is 10 to the power 1.97, 93.33 or so. And then to find d is going to be the gradient. So let's pick some points to calculate a gradient from. We should pick the largest and smallest points I can. I get the gradient is going to be the change in height value, so that's between 2.39 or so down to 1.97, and that's going to go over between negative 0.3 and 0. So if I put those into a calculator, I get 2.39 minus 1.97 divided by negative 0.3, and I get negative 7/5 or minus negative 1.4. That's my gradient, and that should be the d itself. I don't have to do any logs work with that because of how it works out. So I calculate c equals 93.3 to 1 decimal place, and d is equal to negative 1.4 to 1 decimal place. And those are my solutions there. We carry on though, and we're asked now to estimate the pressure of the gas when the volume is 2 litres. Well, here I'm going to use this equation to work it out. In fact, I can put it straight into there. I want, if I look for part C down here, make a bit of a space for me. I want the pressure when the volume is 2. Well, I know C, which is 93.3, times the volume, we said is 2 to the power of negative 1.4. And I simply put that in the calculator and I should be sorted. So 93.3 times 2 to the power negative 1.4. And I get 35.35. And I ought to put some units in. Let's see what the units are measured in here. Does it give me? Pressure in kilopascals. Kilopascals. 35.35 kilopascals, or PA it should be, sorry, is my final answer there.